Yeah, good evening, everyone. Am I audible?
Yes, Himanshu, you are audible.
Yeah, okay. Okay, so I think we should start. So, good evening, everyone. So, I welcome you all to this webinar on power introduction to power electronics in electric vehicle. So, we know that the EV, and nowadays we have seen a boom in EV. So, talking about the power electronics section. So, if we imagine the electric vehicle without power electronics, we cannot imagine. Why? Because power electronics, all the things like if we say about the different components into the electric vehicles, either they are battery, motor, so they stores or they work upon different form of energy, either AC or DC. So if we talk about the battery stores energy in the form of DC. And let's suppose if we are using a AC motor, then we require a power electronic component or a converter, which what will it will do? It will convert the DC to the AC. Okay. Then if we talk about the high voltage side and the low voltage side, so if I talk about the auxiliary components into the electric vehicle, like the headlight as well as the turn light and the other components, auxiliary components into the vehicle, electric vehicles, so they are operated onto the low voltage. So to step down the high voltage to the low voltage, we also require a power converter. So we will talking about those converters step by step, and we will also talk about like how much the power electronics impact create an impact upon the create an impact upon the electric vehicles step by step. And at the last we'll discuss about like how we can gain more knowledge upon these power electronics components and how we do the simulations and the modeling of the power electronic converters onto the MATLAB. So the agenda of this webinar. So I will be talking about the fundamentals of power electronics. Then I will be talking about the components of the power electronics in EV, like where we are using a power electronic component. Either they are on to the charger side, the discharger, as well as the buck converter, the for stepping up as well as the stepping down. Then for AC to DC conversion, the DC to DC as well as the DC to AC conversion. Then we'll talk about the efficiency and performance enhancement in the power electric vehicle. So what we'll be talking about, like how we calculate the efficiency and how the power electronics create a very good impact enhancing the electric vehicle performance as well as the range. Then we'll talk about the power motor controller and acceleration. So if we talk about the motor control, so to control the motor at different speed, because electric vehicles have a very dynamic response, like sudden increase and decrease of the speed. So to control that is speed change or RPM change of the motor, we use a motor drive. So motor drive, what does it do? It is just nothing, just a combination of power electronic switches, or we can say the combination of switches. Based upon that switching technique, the speed varies as well as the conversion from AC to DC or DC to AC is being done. Then we'll talk about the modeling of converter at the last. So we will be discussing that how we can design a converter onto the MATLAB. So what are the steps we do, what are the requirement we need to do, as well as what are the basic calculation we require to do so. So first of all, we'll talk about the fundamentals of power electronics. So onto the screen or onto the slide, you can see like we have the BJT, the diode, FET, IGBT, SCR, GTO, DRIVE, and the DIE. So all these are the power electronic switches. So as we talk about the diode, so we know that diode, it has the two working mode. First one is the forward bias as well as the reverse bias. So onto the screen you can see. Yeah, so the positive terminal and the negative terminal. So when it is forward bias, like when the positive part is connected to the positive polarity, then it is the switch is on and elsewise it is off. Then we have the BJT, then we have the FET, IGBT. So as we talk about more about the switches, we have also MOSFET, and these switches, like most of the power tonic converter, like if we talk about the rectifiers, the inverters, or the DC converters. So what do they have? They have simply the combination of switches. Like the switches are connected into a series or parallel configuration or according to the configuration, and depending upon the switching technique, the required output we get. Simply if we observe about the different switching circuit, or we can say the different circuit of the power electronics converter. So we will be seeing that these components, like either they are diode, SCR, or the GTO. So combination of these switches enhance do the sorry, do the required conversion. So if we talk about diode, so if we are using a diode into a rectifier circuit, then it is called as uncontrolled, because once the switch is on, then we can say, then we cannot turn it off until and unless we do the reverse biasing. Then we are using a SCR, which is thyristor also, so it is having a gate. So whenever there is a forward bias, we have to give a pulse. What do the pulse do? It simply turn on the circuit. So this is there are different functions as well as the operating conditions of the different switches. Based upon that, the power electronics converter is being designed. Now we talk about the fundamentals itself, like we have seen about the diode SCR. So they are mainly made up of silicons, but nowadays this silicon carbide and gallium nitride, these switches are gaining more and more popularities as due to their high band gap, and also they are providing us a high switching frequency, as well as they are capable. So you can see onto the screen like silicon carbide. So it has so this much of thing is of silicon. Then we have here the violet part, which is about the gallium nitride. So you can see the switching frequency. So it is very large as compared to the silicon semiconductors. And then we have the silicon carbide. So you can see the switching frequency as well as the power output. It is also far better than the silicon. So nowadays, because of their high bandwidth, the silicon carbide as well as the gallium nitride, so these switches are this kind of semiconductor are gaining more and more popularities. Now, first of all, now we'll talk about the efficiency and performance enhancement in electric vehicle, like how this efficiency as well as the performance enhancement in EV is responsible because of the power electronics. So can anyone tell me from the participant, like if we want to enhance, like what are the different losses, how we can mitigate, and like into the switching techniques, how we can mitigate those losses? Can anyone from the participants can tell me?
Sir, which type of losses we consider?
Switching losses are there. Because of switching, there are some losses occurs. Also, there are some conduction losses, the heat dissipation into the switches. Because of that, some losses are also seen into the power electronic devices. Because of that, their efficiency is not 100%, but like 90% or 95 or 80% in between that itself. Yeah. So if we talk about the efficiency, so efficiency is being calculated. You can see onto the screen, like simply calculating the output power and the input power. So if we divide the output power by the input power, we get the efficiency. Then if we talk about like where is the efficiency, if we see the generally the power tonics which converters have the efficiency ranging from 80% or 60 70% to 90%. So there is a loss because of the factors. Onto the screen, you can see like we have the switching losses, then we have the conduction losses as well as the heat dissipation. So switching losses is about 1 to 5%. Then we talk about the conduction losses, which is about 0.5 to 2%. So can anyone tell me like what is conduction loss?
The heat is transferred from one place to another.
Then what is heat dissipation? Yes, can anyone tell me like what is the conduction loss and yes, I'm just asking about the conduction, like what does it mean?
It is the loss when the current is being conducted, or when it is the MOSFET is in the on state
Okay, like
due to flow of current. There are some losses occurring.
yeah. So because of flow of electron or the current, there is
Due to
some
resistance.
resistance. Then we have the heat dissipation. Then we have the switching losses. So in power tonics, if we talk about the impactful conversion, we can say that because of this switching of the power tonic devices, we get the required output. So in during the switching, we have also seen losses. So can you from the participant, can you tell me like how to mitigate this switching loss? Like
We can use a lower free switching frequency for mitigation.
So if we are using the lower frequency switching, then it will create an impact upon the power tonic devices. Like I will show you from the upcoming slides. Like if you are using a low frequency switching devices, what will happen? So I don't think so. So just tell me like what are the methods how we can mitigate the switching losses.
Sir, we can use the material like gold or silver plating, and also
That is
we can enlarge the conductor size.
yes, enlarge the conductor size. So what will happen? It will simply increase the size of the converter.
So we can eliminate corrosion.
So, sir, we can do it by, depends upon the frequency.
Yes.
So maybe we can reduce or increase the frequency accordingly, and then according to that, we can reduce the switching losses
Yes.
when
So
there is power transmission.
the frequency, like because depending upon the frequency, we can do either the soft switching, like there
Yeah.
are different components which are like efficient for performing or to mitigate the switching losses. Like it will not eliminate it completely, but it is being reduced.
We can vary.
It is reduced.
Yeah.
So these are the factors: soft switching, conduction loss, and the heat dissipation, which are responsible for impacting upon the efficiency. Then we talk about the importance of power tonics in EV. So if I say if we are using energy conversion component into an electric vehicle, so if it is providing a good efficiency, then we can say that it can enhance the performance of the electric vehicle. Like if we are using a power inverter, so basically inverter, what does it do? Can anyone tell me inverter, working of inverter, what does it do?
It convert AC to DC and vice versa.
Yes.
It converts DC to AC.
Who was who was saying this vice and versa? Yeah, so inverter simply converts DC, like in your home or in our home we have seen the battery pack. The battery stores energy which is in DC, but inverter, what does it do? It converts that DC to AC. Now, so if we are using a power electronic, or the inverter, and it is having a good efficiency, then the conversion of DC to AC will be better. So because of that, the electric vehicles will provide a better efficiency, and also it will give a range.
சார் ஒரு டவுட்டு. ஹலோ சார், இந்த ஃபேக்டரி இன்ஃபுளுன்சிங் எஃபிஷியன்சி அது எப்படி ஒரு காக்கும் சொல்லுங்களேன்.
Yes, I didn't get you. Hello. Yes, what was the question? I didn't understand. Okay, so if he's, so I don't know. Okay. So now I talked about the importance. Then we talk about the challenge and the improvement. So what is the challenge? So like the introduction of silicon carbide and the gallium nitride, what happened? We get a wide gap semiconductor, like wide energy band gap. Because of that, the switching frequency as well as the power transmitting capability of the power electronic switches is being increased. Because of that, the efficiency of the power electronics is increasing, and because of introduction of this silicon carbide and gallium nitride, there is reduction in losses by 50%. So this is about the efficiency we talked about, into the electric vehicle, which depend upon the power electronics conversion thing. Now coming to the next part, which is about the AC/DC, the DC AC and the DC chopper. So first of all, we talk about the AC to DC converter, which is a rectifier also. So if I talk about the rectifier, so can anyone tell me like how many types of rectifiers are there?
So controlled and uncontrolled rectifier.
Two types.
Based upon controllability as well as the half wave, full wave, and also like the center tap.
Center tap.
Yeah. So
Bridge
center tap,
rectifiers,
bridge rectifier, yes.
single phase, three phase, single phase.
Single phase, because depending upon, so there are lots of factors like the phase, the controlled part, controlled and uncontrolled, and also the full wave, half wave. So based upon different, you can say different comparison parameters, you can differentiate the rectifiers. So if we talk about AC/DC, simply what we use, like the combination of switches, and either they are diode, SCR, diac as well as a triac. Because of this switching, like if we talk about the switching, we arrange the switches, and because of this arrangement, we give the pulses to this, or you can say the AC supply to this rectifier, and because of that, we get the DC at the output. Then
Hello, sir. It's not audible.
Okay, sorry. Yeah, now it's audible.
Yes, sir. Sorry.
Yes,
Yes,
sir.
yes, yeah, it's audible.
Yes. So I talked about the inverter, which is VSI and CSI. So can anyone tell me like what is the main difference between CSI and VSI?
VSI is voltage control rectifier, and CSI is current control rectifier.
Rectifier.
Inverter, sir.
Yeah, inverter. So if we talk about the VSI, the voltage source inverter, and the voltage is being kept constant. But in case of CSI, the current is being kept constant. So if I talk about more about the circuit, or if you go more into the circuit, so you guys will understand like how the switching is done, and depending upon the switching technique, like when to turn on this switch, when to turn off this switch, like we have the sequence. Based upon switching sequence, we get the required output. Yeah, then we have the choppers. So choppers, like we have seen a DC to DC chopper as well as the AC to sorry DC to DC chopper. So what we talk about this chopper, so it is responsible for conversion of DC to DC, either to step up or step down. So can anyone tell me for AC to step up and step down, what we can do? Like what are the components which is used to the AC step up and step down? What is the name of that?
Transformer.
Transformers.
So why
Step up
this
transformers, step down transformer.
Yeah, transformer step up down and step up. So why DC is not being used in transformer?
It is only for the same frequency.
Yeah, because this DC didn't have any frequency component, so this DC is not being used into the transformer. So if we see about the equation of the voltage of the transformer, we can see that there is a term F into that. If we apply DC, then there is no F, then because of that the transformer will not able to generate a voltage or induce a voltage. So these are the basic components: rectifier, inverters and choppers. Now day by day what is happening, there is more enhancement into these components, like we are using ICs, and also we are using closed loop control, the interleaved and the converter. So there are many new research as well as the innovations happen into these rectifiers, inverter and the choppers. So day by day, these converters are providing a very good efficiency. Now, let's talk about the main components of the EV. So here we can see this is the battery pack, and here we have the motor. So I already discussed this part into the beginning, like the DC stores the AC, DC. We have the motor. So let's suppose this motor is having this motor is a AC motor. So for do the AC to DC conversion, we have a inverter which is assembled, and it is responsible for the required DC to AC conversion. Now here you can see this is the charger, like this charger. Let's suppose this charger is an AC charger. Now we want to charge our battery pack. So what will happen? This for charging the battery pack, we require a DC power and DC power. So to convert the AC to DC, we have another converters that is onboard chargers, mainly told into the EV term, but it is basically a rectifier which is responsible for conversion of AC to DC, and because of that AC to DC, we are able to charge the battery pack. So these are the basic EV components you can see onto the screen. Like the lithium batteries, the quick charging, this is for maybe for the DC fast charging. We talked about this inverter, then we have the motor here, and these are the mechanical components like the axles. Then we have here the power tonic converters. Now coming to the next slide, which I am focused. motor, which is an induction motor, or you can see a AC motor because it is having 3 phases. So this you can see here the diodes or the switches. So they may be either diode, MOSFET or IGBT. And we can see the anti-parallel, like the diodes is being connected into the anti-parallel configuration. So what happens here, depending upon the switching techniques, like we have here the ECU and the compressor for the motor assembly, then we have the MG-ECU, and which is a DC converter here also present. So depending upon the controller, like the driver feedback, the EV control units give the required command to this inverter, like this is a motor drive. So this is basically doing the DC to AC conversion, and based upon that this motor is being excited and we are able to move the vehicle. So this is about a basic motor control. Like we can see an inverter, which is nothing but a combination of switches, and because of this combination of switches we are able to drive the electric motor which is being used in our electric vehicle.
So what is this MG-ECU?
So it is a electronic control unit, like the MG is, I think, so MG is the name of the brand, like MG-ECU. It is electronic control unit and the EV control unit. So the senses, like the whatever the required current as well as the voltage which is being given to this control unit, and then it is being transmitted further to this inverter. Yeah. So this is about a motor control and acceleration thing. So now we talked about the basic of this, you can say, converters. Now we'll move towards the modeling part because we have the idea of the components as well as the converters, but how we do the modeling, what are the different equations, what are the steps we do, and if we given a problem statement, what are the basic calculation we should do to get the required output. So I will be designing a buck boost converter. So boost converter, what it is, can anyone tell me?
To convert the low voltage DC to high voltage DC.
Yeah, low voltage DC to high voltage DC. So here are the so we will be designing a buck boost converter onto the MATLAB software. So for designing, we must have a problem statement, like what is the rating and what are the things we are required to get the required calculation. So first of all, let's say, like, I want to design a boost converter. So the input voltage, let me assume that I am taking 24 volt. Okay, so kindly do the practice like calculation with me. So let's suppose I have a 24 voltage at the input, and at the output I want, which is, you can see here the V0. So at the output I want 48 volt. At the output I want a 48 volt. So based upon this output voltage, which is nothing but the V0, and here the Vs, which is the supply voltage or the source voltage, it is 24 volt. Now based upon that, we will be calculating the D value here. So you can see the D, which is nothing but the duty ratio. So can anyone tell me what is duty ratio? Yes, can anyone tell me, like, what is duty ratio?
The time in which the device is on.
Yeah, like it is the ratio to the total time, to the time in which the switch is on to the total time period.
0.5.
Yeah, like for how much cycle it is being turned on and turned off. So that is the duty ratio. So if I want to calculate the duty ratio, so what will be the value from the participants, can you tell me?
0.5.
Yes,
0.5.
0.5. Okay. So we have calculated here 0.5, which is the duty ratio. Now let's see the other component. So here we have a inductor, and this is a diode, and this is a switch, and this is a capacitor. So like I want to design a circuit for, let's suppose I want to design a circuit for 200 kilowatt, 200 watt. So what will be the value of R? Can anyone tell me? Yes, just simple, very easy calculation. Yes, my question to you is, like I want to design a 200 watt buck and boost converter, and at the output I have 48 volt. What will be the value of resistance I need to put here to get the 200 volt and 200 watt power? Yes. Like simply use P is equal to V square upon R. So if I
0.52, right?
11, I didn't know, just you guys tell me, like 48 square upon,
2.8.
It's 11.52, sir.
okay, it's 11.52. Okay, so like the power, so this R value, I got it for 200 watt, I got it, it is
52.
11.52, okay. Yeah, so 11.52, okay. So now we have calculated the D value and the R value here. Now we will be going for L. Yeah, others Dubai, I got it. It's 11.52. So just look at here. This is the frequency. So initially I told like we always want a high switching frequency here. Like this F value should be high. Can you tell me like why we want a high value of frequency, switching frequency? So this F is for this switch or the chopper, which is like the, you can say it is continuously turn on and turn off. So why this switching is high?
To reduce the transient loss.
To reduce the transient loss, that we can use the filter circuit now. So if you are implementing a filter circuit by this, to have constant value output voltage. Yeah, just tell me from this equation. Like this is the equation to reduce the transient time. Like if there are any errors, so what about if it is becoming a undamped oscillation, like oscillating, there is no constant value we get. For transient, that is another thing. Like you can say by implementing a filter circuit and different value of additional value of capacitor and inductor, we can eliminate the transient. But for frequency, why I am saying that we have to consider a high switching frequency devices.
Sir, actually, when frequency get increases, the inductance value decreases, sir. So that the current lags, so voltage gets stepped up.
Yeah, like there is, yeah, you are right. Like, but you said that the current lag, and that is not. So basically, if we are using a high frequency, what will happen? This inductor value will be reduced, and because of this reduced in value of this inductor, what will happen? The component or the product which the manufacturer is developing, the size of that will be reduced. So that is the factor why we are using high frequency. Similar for this capacitance also, we are using a high frequency. So because of using high frequency, the value of this inductor is decreased, and also the value of capacitor is also decreased. So this is the basic thing from this equation you can understand. Like we are increasing, if we are using a high switching frequency device, then we are able to reduce the size of the components, either they are inductor or capacitor. Okay. Now, if I talk about the working of this circuit, so let's suppose I turn on this circuit. So what will happen when I turn on? What will happen? The current will start flowing into this circuit. It will not going after this, like it will start flowing Vs into this loop itself. Yeah. So it will start rotating into this circuit. When I turn off, what will happen? This diode will become turned on, and the current will start flowing into this. So there is a whole complete analysis of this circuit. So I didn't have that much of time so that I can explain all the working of this buck converter, like how we use the equation. So simply when I turn on, the current will flow into this circuit. When I turn off the circuit, like open this circuit, what will happen? The current will start flowing into this circuit. Yeah, and because of that, we'll get a value, different equations, and because depending upon that equation, we calculate the value of D, we calculate the value of L and the C. So we have here, now we'll go for calculating the value of L. So can anyone tell me, like we have the D and we have the R value here. So what is the value of L? Can anyone tell me?
So we should know F no, sir.
Oh, sorry, I didn't. Let's suppose I am giving F here to be 40 kilowatts. Let's take 40 kilowatts.
How do we choose F?
So like simply you have the catalog of the different switches. Depending upon that, like what are the frequency of the switches. Like if you see the MOSFET catalog or the IGBT, so you will be seeing that this much of frequency they are providing. So depending upon that, we choose this.
Okay, thank you.
Yeah. So I hope everyone is calculating the same value. Yeah. So what is the value of L?
0.08.
L it is. Can I do the useful calculation, because I am not calculating? So if any error. So what is the L? Let me check to the chat box. Yeah, so L it is microhenry, 18 microhenry. Someone has written 18 microhenry, someone has written 0.018 microhenry. It's 18. Okay, so I'm taking here 18 microhenry. Okay. Okay. So then what is the value of capacitance? So this is the ripple voltage. So let's consider its value as 5%. Let me tell you that. So if I tell it 5%, so this value will be 0.05. Yeah. So this value is 0.5. Yeah, so what is the value of C?
$21.7 microfarad, sir.
What is, how much? 21 microfarad. Okay. Okay, so we have calculated all the components value. For inductor it is 18 micro Henry, and for C it is 21 microfarad. So now we'll move toward the MATLAB. So we have all the component value. Now let me open the MATLAB. So this is the MATLAB. So here you can see the different operations. So we are going to use the Simulink. So let me just open the Simulink. By clicking on Simulink, we are moving into the simulation part of the MATLAB. Yeah. So we'll create a blank model. Yeah, just wait, it's just taking few times.
Sir, how are we compensating the higher losses and the EMI
Like
effects
they are
due to the switching?
different techniques. Some are using interleaved, like there are also few converters with enhanced performance like CPEC, cup converter. So these are like ZSZV. So these are the new techniques which we are using to eliminate the losses. Either they are switching losses, the conduction losses. So because of this, we are able to mitigate the losses, and we are getting we are enhancing the power electronics component efficiencies. So now we'll start creating the model. Let's see, we have a voltage source, DC voltage source, we have an inductor, we have a switch here, then we have here the diode, then we have here capacitor, then we have here a resistor. So according to that, we'll start calling the components onto the MATLAB Simulink, then we'll design and try to get the required output. Yeah, just wait. So just call for a DC voltage source. This is the MATLAB workspace. Simulink workspace, we'll click onto the library browser. Now we'll call for a DC voltage source.
Sir, I think your screen is not shared, sir. We're not able to see your screen.
No, sir, it's visible.
Visible, sir, visible.
Himanshu, please share your screen again.
Yeah, it's there, sir.
No, we are not able to see, sir.
No, not visible, not visible.
Yeah, now it's visible.
Yeah. So simply go to the library browser, then we write here the DC voltage. Just you will see this voltage source and just copy it. So we'll drag it and place it here. Just wait, my MATLAB is a little bit slow. Yeah. Now we'll call for a series RLC branch, which is nothing but RLC circuit. Yeah, this is the branch. Just click it. Place it here. Now we require a inductor. So what we'll do, we'll make a copy of it. One for inductor, one for capacitor, and one for resistor. So simply double click it and branch type, click on first one for inductor. Then we have here for capacitor. Then we have here for resistor. So now according to the circuit diagram, we'll arrange it and then we'll start doing the connection. So before that, we'll call for MOSFET here, MOSFET or IGBT. So I am calling for MOSFET. Yeah. So this one is the MOSFET. Yeah. This is MOSFET. So I will simply copy it here. Now we want to give a switching frequency to this MOSFET. So for that, what we'll do, we simply double click onto the screen and call for pulse generator. Like we want to give here the duty ratio and the pulse generator. So for that, we'll click onto the pulse generator block. Yeah. Now we'll do the necessary arrangement. So first one is the source. Then we have here the diode. Then here we have a MOSFET. Then here we have a diode. So I forgot to call for diode. Just go to the library and call for diode. Yeah, so this is the diode. Simply make it copy it here. Okay. Now we want to measure the current as well as the voltage. So for that we call for voltage measurement, which is this is the voltage measurement. Then we want to see the value. So for that we call for scope. Yeah. Now we'll give here, put the value. So if I talk about the pulse generator, so amplitude, let it be 1. Then we talk about the time period. So what is the frequency of the switches, which is 40K. Now to know the time period, how we know the time period?
Why not 25 milliseconds? Micro.
Yeah. So simply I can do 1 divided upon 40.
25 micro or 0.025 milli?
So I can write like this also. Now, what was the duty ratio? So pulse width, I have to write according to that. So it was, I think, 0.5. So here for 0.5, I will write here 50%. So this is the all value we have given for the switching. So we'll simply click onto the apply and then click onto the OK. And now this will be going to this get pulse of this diode. Then we have here the diode. Here it is the L, which is the inductor, which is connected to this MOSFET, and then we have the diode here. Then we have here the this capacitor. Then we have here the resistance. So let me remove this. So the parameters of this MOSFET should be default. Yeah. Now we'll call for power GUI, so which is giving the power to the blocks, which is present onto the Simulink. Yeah. So initial voltage, I was assume it was 24 volt. Then the value of inductor, what is 18 micro. Inductor value, what was it?
18 microseconds. Micro Henry, sir.
Yeah. What about this? Yes.
I think your internet connection is very slow, so your screen is stoppable.
No, I think so. You opened the capacitor block. So is it visible to you?
Yes,
sir. Visible.
Yeah. Yeah, it's 21 microfarad. So simply write here 21 microfarad. So I have put all the value. So what was the value of resistance?
11.52.
7.52.
11.50.
11. Yeah. So now I want to run this simulation for 10 seconds. So we have given all the values. Now just click onto this run button and then we'll see at the output, like what is the output. Yeah, we have completed the simulation. Now we'll open the scope log and see the value. So our requirement was about 48 voltage. So let's see, we are able to see calculation. Please tell me. Okay. So we can see here, there we are about near about 48 volt because of there is some ripple we can see onto the screen. So either we have to connect a few RLC circuit here or the filter circuit so that we can reduce those ripple, because here we are seeing that there are some ripple present. Like if we zoom in, if we zoom in, so you can see it is near about, our requirement was 48 volt, but there are some ripple present. So it is due to the value of like we have to use external filter circuit, or we can enhance the resistance this inductor value. So I think we have the value which is 18%. So let's suppose for safety consideration or to reduce the ripple, we should take it like 20% or 30% more as required as per the calculated value. So whatever the value we have calculated, let's suppose it's 18, so we must take about 20% more than 18 so that we can get the required output. So here we have achieved the required output, but there are ripple present into the circuit. So to eliminate that ripple, we need to do the further calculation of the inductors. So this is how we have designed a boost converter onto the MATLAB. So someone asked about the calculation of C. So from C, like here we have can see the capacitor. So we have here the duty ratio, and this is the resistance value, and we have here the ripple. So this is the ripple and this is the frequency. So frequency we have, the R value we have, and we have here the ripple. So ripple, which is basically the 5%. So we will see we will be using 0.05 instead of this value. So this is how we have done about the MATLAB, learn about the power tonics, like the efficiency, about the efficiency, how the efficiency plays an important role in enhancing the range of the power tonic components. Then we have talked about the EV, like the different components into the EV and where are the power tonics being used into the electric vehicle. Now we also design a modeling and converter. So that was, thank you. That was all from my side. Now, if you want to ask any questions, so we can. Yeah, thank you.
Thank you, sir.
Thank you so much, sir.
Thank you, 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 sir.
Thank you so much, sir.
Thank you, sir.
Thank you.
Sir, is it recorded?
Thank you, sir.
Hello, sir.
Okay, sir. Hello, sir. Sir.
Hello, sir.
Hello, hello.
Sir, how can we able to get the certificate, sir?
Hello, Lonus. Thanks for attending the webinar.
Ma'am, how we get
Also
the
to
certificate?
enhance- That will be in the link, will be provided in the chat box. Okay. Okay, so here I would like to introduce ISIE India products, which will help you enhance your skills. So come take a look of a small video about ISIE India courses that helps to enhance learning and gives the opportunities for the placement. Have a look.
Okay, ma'am.
Ma'am?
Hello, engineers. Do you also want to expand your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISI India has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, global wide certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV, CAD, and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV, CAD and CAE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling and upskilling, at engineering institutes across India, we are setting up a state-of-art facility, Center of Excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation and product design and development. It is a combination of 6 labs including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab and renewable energy lab. Each lab is consist of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine cutout section workbench, 2-wheeler, 3-wheeler, 4-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
Thanks, learners, for watching this video. Hope you guys have understood the products. So any of you wants to enroll in this course or interested in the course, kindly send us the inquiry through a QR code displayed on your screen. This QR code is only for the enrollment in the course, okay? Not for the certificate or feedback.